everybody. Welcome to Loss of the Night. My name is Helga Kuechly.
And I'm Christopher Kyba, and we're coming to you with a bit of a tape delay from the German Research Center for Geosciences. And we're excited to be kicking off a 24-hour global observation campaign using the Loss of the Night app, which is for studying light pollution. So before we get into the details of the app and how to use it, Helga's going to tell you a bit about why we are interested in light pollution in our work.
Yeah, so I want to start off with a personal story. In my 20s, I went to a festival close to the Main River, and while I was walking outside, I suddenly noticed all this white stuff on the bridge crossing the Main River. And first I thought it's snow, but snow in summer, flower petals, but there were no trees close by. And then we walked up to the bridge, and I just realized it's all mayflies that were hatched in the Main River, then were attracted by the streetlights, trapped and died of exhaustion. They even had snow machines carrying away all the dead bodies. Nowadays, a lot of municipalities actually turn off the streetlight when these mayflies hatch to prevent it from happening. A maybe less extreme example of the power of night are these mosquito traps that you might have seen before that attract insects with the blue light and kill them, so they hopefully don't bite you anymore. But one thing with light at night is that we generally have a very positive association with it. So for a long time we just neglected all these impacts that light has on insects, and only recently, more and more research came out that suggested that light could be one of the key drivers of the current insect decline. But it's not just insects that are impacted by the light. Actually, 60% of all living creatures are night active and therefore really impacted by the loss of true darkness. Now, why should we protect the night? There are more reasons that we should protect the night. So I already mentioned ecology, but also concerning climate change. We really should think about if we need to waste all this light, which of course is wasted energy. There's been a study that estimated about 5 billion euros could be saved in Europe alone. And also with all this light pollution at night, we kind of forget what a natural night looks like, especially in Europe and in the US. 99% of the people live under a light polluted night sky and therefore hardly ever can see the Milky Way and connect to the stars and the old heritage and tradition. Now, I want to give you an example of what the night sky looks like where we are at GFZ in Potsdam. Only a few hundred stars are still visible. And if we travel further out of the city, we're very lucky that the Milky Way becomes visible. But what we can see here in the image is the light around the horizon is still light that traveled from Berlin nearly 100 kilometers to Lake Stechlin. So it's not just the immediate area that get impacted, light travels far distances. Now, what we are interested in is measuring this light pollution and also monitoring it. And one great way of doing that is with a so-called naked eye limiting magnitude. It basically looks at the brightness of the stars. So here we have the magnitude 7 and 6 on the natural sky, and the further we get to urban areas, the less stars become visible, and only the brightest are still on the night sky. And this is basically the methodology that the Loss of the Night app takes advantage of, that now Chris will tell you more about.
Thanks, Helga. So to use the Loss of the Night app, you've got to download it either on the App Store or the Google Play Store. And then you look at your phone, you go outside at night, and your phone is going to show a circle and an arrow showing which direction you're supposed to look. So you'll be looking at your phone, and you'll change your body position and then tilt up into the sky, and then you should be able to see some stars on your phone, and if you look into the sky in the same direction, you'll see the stars there. So you're not going to use your phone's camera, you're going to use your real eyes to look past the phone at the stars and let us know whether you can see them or not. And when you look at the app, you make a decision about whether you can see it with your naked eyes or whether you can't. And if you can't, then there are a few options you can tell us. For example, sometimes we'll suggest a star that's behind a tree for you. You can let us know an object is in the way. Or sometimes you might not be sure about whether you could see the star or not. So I want to show you what the data actually looks like when we collect this data. So on the graphs, I'm going to have this naked eye limiting magnitude that Helga mentioned. It's a very old unit. It goes back to the ancient Greeks, who said that the brightest stars were magnitude 1 and the faintest stars were magnitude 5. If the magnitude 5 stars are visible, that means you can see a huge number of stars. So on the vertical axis, we'll have the stellar magnitude, and on the horizontal axis, the observations that each person had over time. So here's our first example. You can see that we've circled the stars that the person could not see. Those are in black, and the stars that they could see are colorful. So you can see that there's not perfect consistency here. There were some bright stars that the person said they could not see, whereas some fainter stars they said they could. And the reason I want to show this is it means that you really don't have to worry if you're not experienced in looking at stars, because we get a measure of how uncertain your observation is by this self-consistency. So you see that red arrow on the side. We know that the sky is about this bright. It's somewhere inside of this range for this person's observations. So now let's look at somebody who's probably practiced with the app more often. And now you can see that uncertainty bar has become very narrow, because in this case, all of the stars that the person could not see were all fainter than the stars they could see. So we can have a really high confidence that this is a very accurate observation. And once in a while we get somebody who really goes way beyond the call of duty. This person looked at 35 stars, and you can see that nearly always the stars they said they could not see were fainter than the stars that they were able to see. So we can have really, really high confidence. It's a very accurate measurement. But like I said, don't worry too much if your first tries are not so accurate. We can see that inside of the data, and it won't make a problem. So why is it that we're asking people to look with their eyes instead of using, cameras or other instruments? Well, at GFZ Potsdam, we also do use other instruments. We use satellites and things. But here's the important point. Cameras and satellites measure radiance in a unit called nanowatts per centimeter squared per steradian per nanometer. Now that probably means nothing to almost everybody who's watching this stream. And say, for example, that we see with the camera that the sky became brighter in blue, but became darker in red. Does that mean that the sky got better or that it got worse? Well, with the naked eye observations, it's a real human experience. And if you tell us that you can see more stars or fewer stars, then that's really something that everybody can understand. So after you've made your observation, you can head over to a website we have called myskyatnight.com. And there you can see everybody else's observations and access your own observations as well, at least if you have provided within the app your email address. So what we'd like to do now is to kick off a global observation campaign. So whoever's watching the stream, if you've got clear skies tonight, head out, download the app beforehand, go outside and give it a shot, and you can check out your data the next day on myskyatnight.com. And if you happen to have cloudy skies tonight, well, no problem. You can still take part for about the next 10 days. The moon will be out of the way, or sometime in the future. But we'd really love to have as many people as possible head out tonight and see how many observations we can get. So with that, we would like to thank you. If the live stream had worked, we would have taken your questions now. We're here. You can send us a question from within the app itself. You can send us a question by email if you want to know something more. And hopefully we can organize another live stream at some point in the future.
Yeah, we're experts now. Thanks for watching.
And thank you very much for taking part in the experiment.
Yeah.